Hey, welcome to the mini lesson about gravity and just how weird it can be. Alright, so let's imagine that we've got an elephant and a little kid, and they're both falling towards the earth. The elephant has a mass of 10,000 kilograms. The kid has a mass of 50 kilograms. Now, the first interesting thing about gravity is that gravity accelerates all objects the same, regardless of their mass. Now that word accelerates, that means their speed keeps increasing faster and faster. So as they're falling, their speed is increasing faster and faster, but the same for each of them. That means that they fall at the same speed as each other if they were dropped at the same time. And the elephant and the man, or the kid, will hit the ground at the same time because their speed is getting faster and faster equally for each of them. Now on Earth, we can put a number to this acceleration. We say that on Earth, the acceleration is 10 meters per second per second. Now that's a little bit weird. 10 meters per second, that's a speed. 10 meters per second, well, that tells us that for every second that something is falling, the speed is increasing by 10 meters per second. Now here's a thought question that maybe will help you understand that weird 10 meters per second idea. How fast would the man and the elephant be going after 3 seconds of falling? Think about that. In the first second, they'll be going 10 meters per second. In the second, they'll be going 20 meters per second for their speed. And in the third second, they'll be going 30 meters per second for their speed. So that's what that 10 meters per second means. And after the fourth second, they'll be going 40 meters per second. All right. Now, when we say gravity accelerates all objects the same, well, to accelerate things, we need to apply a force to them. And a big force is needed to accelerate a big mass. You know that from your experience on Earth. You need a big force to move or accelerate a big, massive object. So this elephant might require 100,000 newtons to accelerate him. But a small force is needed to accelerate a small mass, like this kid. He might only need 500 newtons to accelerate him. Now, there's a formula that can connect the acceleration from gravity to the force needed to move a certain mass. That's acceleration equals force divided by mass. We'll use that formula more later in this unit. So, let's apply this to both of these guys and see if we can prove that their acceleration should be exactly the same. So, the elephant requires 100,000 newtons to move him or accelerate him. The kid requires 500 newtons of force to move him. The elephant has a mass of 10,000 kilograms. The kid has a mass of 50 kilograms. If we do the math and divide these numbers, it turns out that the acceleration in each case is exactly the same. It comes out to 10 meters per second per second. So there, we just proved mathematically that objects that have different masses will accelerate the same and fall at the same speed on the Earth. Now, let's go back to just a bunch of different objects and think about it in a little more simple fashion. These objects all have different masses. The elephant, the guy, the soccer ball, the house, the ant. But you know from your life experience that to move these objects would require different forces. More massive objects require a big force to move them. Less massive objects require a little force to move them. But the weird thing about gravity is gravity provides exactly the right force to accelerate every object at the same rate. Now, here's another way to think about gravity. Hi, I'm gravity. I am very sensitive. I don't want anyone's feelings to be hurt. I pull with different force for different masses, so falling objects will always have a tie. Isn't that nice? Everyone is a winner! Hey, I'm buoyancy. I make liquids and gases push up on objects, but I affect flat and lightweight objects more. Darn you, buoyancy! Buoyancy from air really messes up my acceleration fairness. Because of you, some flat and lightweight objects fall more slowly, like parachutes and feathers. If a person jumps out of a plane without a parachute, they'll fall at a very fast speed. But if a person jumps out of a plane with a parachute, they can fall quite slowly. And everyone knows that here on Earth, if you drop a feather and a rock, well, the feather's going to fall much more slowly. And that's all because of buoyancy. Buoyancy messes up the acceleration fairness of gravity. Now, right after this clip, you're going to watch one or two videos that will show you that if we take away the air and we take away the buoyancy, we can see that gravity fairness. If you drop two objects like a feather and a hammer in a place where there's no air, like on the moon, or if you drop some objects like some feathers and a bowling ball inside a giant room where there is no air, they will fall at the exact same speed. So if you can take away the air, you can take away the buoyancy, and then you can really easily see the fairness of gravity as it accelerates all masses exactly the same.